Well, good afternoon. Welcome to Build 2014 afternoon session. Can everybody hear me? I can hear me. Good. All right. Well, my name is Steve Wright. I'm here to present a talk on desktop development in Windows 8.1 and the update. I've been a program manager at Microsoft for almost 2 decades now, and I've worked in a lot of input and output technologies over those years, and I'll be talking a lot about some input and output technologies that are important to desktop developers. So let me just see if I can use this one. Does this work? Excellent. Okay, so a brief agenda. I wanted to give an introduction, and I've done that part. Then I wanted to talk a little bit about the Windows platform vision, the architecture, because the story for desktop development is a little bit different than the theme for the Universal Windows application model that a lot of this conference is focused on. And then with that in place so that we are on the same page as to what we're talking about for desktop development, I want to take a look at a lot of advances in form factors that have occurred over the past few years, specifically for input and output. And then I'm going to spend a fair amount of the talk talking about dense displays and scaling your applications on the desktop. I'm going to spend some time talking about the unified pointer event work that we've been doing in Windows and how that applies to desktop development. And then I'll kind of wrap up, and I've got a pointer to some other talks that I think would be interesting to desktop developers. So here's a snippet from that platform overview that you've probably seen in some other talks. A version of this was shown in the keynote this morning. I didn't capture the last tweak to that. My apologies for that. But I think this is kind of a good high-level view of what the Universal Windows application model looks like. It's very focused on XAML, HTML, JavaScript, and this new Windows runtime layer. Now, my only problem with this slide is that it doesn't show exactly how the desktop fits in. And I think that's just because it was developed to focus very clearly on this whole new unified thing. And frankly, a lot of what we're talking about at Build this year is focused on phone, making the phone apps work on the desktop, in Windows, having that write once and deploy everywhere kind of thing. And so for those purposes, this is a really good picture. But there's some things we need to add to it to understand where the desktop fits in. The first thing is that there's this intermediate layer above just the basic Windows kernel services. So this is kind of above Windows NT if you think of the fundamental OS. But it's also below the Windows runtime, and it has a whole set of input and output capabilities. This is very similar to a slide we showed last year. And so a lot of what happens with the touch-first input actually comes from this box that's called Input, Interaction, and Manipulation. And a lot of what happens with our modern graphics output is in the box on the right, the desktop composition that gives us the unique desktop experience, performance with media, game playing through DirectX, and a lot of other components which now are layered on DirectX. So we really need to call that layer out. And the reason we need to do that in particular is because those layers also underlie the desktop. So all the work we've done in this space for the Universal Windows application model also is very important to desktop. And if we push them to the side and make room for some of the desktop stacks that you're familiar with, you see we also have HTML there on that side, web programming. We also have the classic Win32 with C and C++. And we have .NET and WPF and Silverlight with C# and VB. So a lot of the work that we've done, even over the last few years where we've been talking about touch-first experiences and better graphics performance, is actually in components that also benefit the desktop. And I want to make sure you're aware of what those are, because there are areas where there are some clear calls to action for desktop developers. So let's skip ahead here a little bit. Let's talk about these form factors now. This has been a big year for form factors. I thought it was a big year last year, but they just keep coming. So let's start with the display side. We're all of a sudden seeing 4K for Windows. We kind of knew this was coming, but it's really hit hard and fast. So this is I think it's a Dell? Yeah, it's a Dell 4K monitor, desktop monitor, 24 inches. It's about 200 DPI. A beautiful kind of desktop device for somebody who's doing industrial design or CAD engineering work. And it's relatively affordable. I think it's around $1,000 or so. You can probably buy it on sale for under that. So that's quite incredible. But 4K also is coming in other form factors. Panasonic has released and is shipping a kind of more of an graphics artist's tablet. If you can call a 20-inch device a tablet, you have to be careful carrying it around. But you can see how a work group could basically take this into a meeting and do collaborative design and so on, and then somebody could take it back and set it back up as a kind of an all-in-one. So that's a 20-inch 4K display, even higher density. At CES this year, just a couple months ago, Toshiba announced that they have aspirations to produce a 4K 15.6-inch laptop. And they're saying they're going to deliver that this summer. They were out there with the CuraBook last year at this time, so I'm pretty confident they can succeed. In fact, this looks a lot like a CuraBook's older brother. So that's 4K in a 15.6-inch form factor. That's 280 DPI. That's starting to get heavy, even for Windows with 200% scaling. Then just below that, there's a lot of form factors coming in 13.3 inches with 32 by 1800 QHD+. One of them is this Lenovo device, which I brought for purposes of demoing something else, which also from a form factor perspective is kind of interesting in that it supports all kinds of different ways of using it all the way around to you can fold it all the way around, use it as a slate, or they call it a tent position. But it's a very high definition screen, and quite a beautiful experience actually. And they're not alone in this space. Their form factor is kind of unique, but Samsung and other vendors are also selling exactly the same kind of 13.3-inch 3200 by 1800 device. Microsoft has its Surface family. If you get down to around the 10-inch frame, these are typically 1080p style devices. So they're also well above 200 DPI. And then it gets crazy. We have these little 8-inch devices. I mean, you've probably all seen the Dell Venue Pro 8 Pro on the floor if you haven't already bought one. A small device, full-fledged Windows device, 8 inches. And right behind it in this picture, I've got Lenovo's got something competing in the same space. So just think of the range here. You've got a 9-to-1 range in terms of surface area, because this is like 8 inches as opposed to 24 inches for that big one on top. And almost all of these are relatively high DPI devices. We're not looking at 1366 by 768 anymore. Another thing to note is that almost all of these devices are touch. The only exception is the big laptop, or the big desktop monitor in back, which you would get into what they call the gorilla arm thing if you were only doing touch with that a lot. But I'm sure we will see desktop devices that big with touch, because you can certainly get smaller ones now that are touch enabled. So, a lot of innovation on the display side, a lot of innovation on the input side. Meanwhile, on the input side, we also have the Xbox and the Kinect for it. We have the little blades, as we call them, that fit on the Surface devices. It's a new keyboard form factor. Pen computing is still going strong. Quite a few of these devices ship with pens, like the Panasonic and even the little Dell. And we've introduced our Precision Touchpad in Windows 8.1, and we've made some enhancements to that in the most recent update. In particular, for those who liked it, and we used to use that feature, there's a kind of a thing called tap and a half drag that lets you select. If you know about it, you love it. If you don't, it's probably like, what in the world? But I'll let you know about it, and you should try it out, because it's really interesting. So all kinds of stuff going on in the input and output space, and this is all very much desktop focused. So that makes it an exciting time, but also a challenging time, because the dilemma you've got is, how are you going to write one set of code that can handle a whole range of different devices, different form factors, different densities, and different input types? And the answer that we provide in both of these areas is that we've done work to provide great abstractions that try to unify the difference, giving you something to code to, and then we will try to handle making that work on different devices. At the same time, we expose the differences. So you can start by writing something that's relatively agnostic or common denominator focused. And then once you've got that in place and it's working, you can begin to add specific code for different kinds of input devices or to take advantage of specific kinds of scaling issues. So I wanted to start talking about the display picture. And some of you may have seen a presentation I gave last year talking a lot about DPI. This is a little bit of a condensed version of that with some news about some developments over the last year. The first key point as desktop developers is that high DPI is an important productivity feature. This is why. This is what text might look like on a 1366 by 768 display. You can read that. It's kind of amazing that you can if you look at the large number of fairly gray pixels. If you double the density, it becomes much sharper and clearer. And it's easy to see why, flipping back and forth. You have more pixels to work with, the grayscales retreat to the perimeter, there's a lot more solid black and white. And that is it can be measured as an improvement in contrast. Here's a couple interesting charts I got from one of our designers on the visual display front at Microsoft. The one on the left is kind of a graph showing as you increase pixel density, and the x-axis is a kind of a proxy for that, then the effective contrast also grows, at least up to a certain point. You can see that as you start to get close to 250, 300 dpi, you pass the point of diminishing returns. But there's definitely a region there where just increasing the number of dots per inch definitely increases the contrast. So that's basically a way of measuring what was pretty obvious from that picture a second ago. The second picture on the right is where the productivity angle comes in. You can also get industrial data showing that your reading rate improves as the contrast goes up. Well, that shouldn't be too surprising. There's a whole lot of data like this. You read faster, you read more accurately, you have less eye strain, you're more comfortable. And so simply moving from low DPI to high DPI devices in productivity tasks gives you an edge, and anybody who's using your machines and your applications has that edge. So that's a really important thing. And I'm also going to make the interesting claim that these little devices are also productivity app workstations. And you wouldn't spend a huge amount of time doing work on this. I mean, we now have the Office apps you probably saw in the keynote, and you can get a really great experience on these small devices. But the other aspect of them that's fairly interesting is that you can use them to drive a different kind of experience. And I don't know if anybody has seen this particular little demo. There's a lot of these out there.
This is all part of the same desktop. If I move a window around here, I can move it around.
So this guy has actually hooked one of these devices up to 4 1080p monitors through a bunch of docking equipment, which his company sells, and it's really cool. But what's interesting is that you could imagine having a lot of work on a device like this and be doing the heavy-duty productivity work where you had to have a lot of documents open at the same time. You could do that at your desk with either, you wouldn't need 4 monitors like this, just one really good large one or 2. But then you could carry this home, you could take it into a conference room, you could use it to project the same material there. So astonishingly, even a very small form factor has a productivity role to play, particularly in enterprise. So I wanted to drive those 2 points home, and then I wanted to talk a little bit about the scaling aspects here. So scaling is going up. Those form factors I showed you originally with those 4K devices shows that there's a kind of a change in the entire ecosystem. I mentioned this last year, but here's a good chart showing just how quickly it's changing all of a sudden. This goes all the way back to like 2002. XP we shipped in 2003, and it only supported 100% scaling. Vista supported more, but we really didn't get a polished experience except at about 125. Windows 7 only up to about 150. And we were able to kind of hold constant there until 2012 when we shipped Windows 8. But in the last 2 years, we've had to push this up dramatically as new hardware was coming. We had to add 200% support in Windows 8.1 for devices like the Kira Book. And we had barely gotten that out the door when devices like this Lenovo came along that really were asking for more like 250. And so we have released 250% support in the spring update when you download that. If you've got one of these devices, or if you had, say, something like that Toshiba 4K, if it was available today, you would see that it defaults to 250. And one hates to say hockey stick, but it looks from this graph like we can expect more increases in the future. And here's some better data on that. So in terms of planning what your applications are going to be running on, our planners are telling us that we should expect to see 150% or higher scaling on mainstream laptops in 2015. At the very low end, sure, they'll still be 100 and 125%. But if you start looking at the entire spectrum of standard and premium, only about 40% will be in those lower buckets. There'll be at least 30% running about 150 and 30% above that. So by this time next year, applications that don't scale well are going to be uncompetitive compared to those that do. And just as a kind of a placeholder in your mind, think of any 1080p device. Everybody's going for 1080p today. If it's under 14.1 inches, it'll be at 150%. So any 13.3-inch device that's running 1080p is going to be running 150%. As we said, there's 4K coming, and there's a nice little chart here that shows just what that will do at 24 inches, 200% scaling. At 15.6, 250. We basically got that out just in time for that Toshiba laptop when it comes out this year. If we start seeing 4K 13.3-inch devices, we're talking 347 DPI. That's going to be even higher. And so we anticipate future releases are going to have to do more work in this space. And what this really raises as a question for developers is, how can I write an app that's future-proofed against this? Because how can I test on devices that don't even exist? That's a problem for us as well. I'll be talking about that in a minute. So I mentioned the 250% scaling support. This is just what it looks like. It's hardly anything new. There's a new button on the one dialog and a new slider position on the other. And these certain devices like the 3200 by 1800 13.3 inches will default to that. And that'll just be the new experience. And again, as always, if you find that you had gotten used to having somewhat smaller text and the like, the slider's there, and you can just adjust it down and get back to the state you were in before. So let's talk about the challenges with desktop scaling. We've spent a whole hour on this last year, and I don't have that much time to devote to it this time. But there are three basically issues. One is, how do you write your code so that it scales? Two is, how do you create assets like icons and the like that scale nicely? And then three, and I want to really emphasize this one because this is kind of, I think, a new issue, is how do you test this without having the hardware in hand? So I'll spend a little bit of time on that. As far as writing the application goes, we've covered this in a lot of detail before. The resource slide at the end of my deck has pointers to more information. We have tutorials, we have sample code. If you haven't done this work before, go off and do it. But basically, you need to tell Windows you're going to scale yourself so that we don't try to bitmap stretch you. And then you have to be proactive about getting the scale factor from Windows and listening for changes in it. So if your application is moved from one monitor to another, for example, you can rescale yourself. What's more interesting is, I think, this issue of how do you test for the bugs if you don't have the hardware? And I recently went through a test pass looking at a lot of third-party code running at 250%. And I saw a lot of bugs kind of like this. But rather than point fingers at my customers, I'm going to point fingers at us, because this is actually our old legacy common file dialog. And you can see that there's a scaling issue. This is a very, very common issue with Win32 code that's been written to start scaling itself, in that what's happened is that the text is getting bigger, but the layout did not. And so at some point, the text starts to overlap one line on top of another. So this is the kind of bug that we've found and had to fix in the past as we increased the scaling level. And you will see bugs like this anywhere you look, particularly in a Win32 application. It's easier if you're developing this universal Windows or the Windows runtime kind of application, because the XAML and HTML frameworks there handle the scaling for you, almost all of it, everything except the assets, and they'll even do a pretty good job with the assets. And so they will just scale up both the text and the layout, and everything tends to look pretty good. But in Win32, because you are responsible for scaling so many different components yourself, it's very easy to overlook one, and in that case, you'll get a result like this. So the problem that poses is, how can you test for these kinds of things? And the answer is, you don't need the hardware. We've come up with a nice little scheme using remote desktop that will actually let you test your apps up to 500%. And that's kind of an arbitrary limit that just happens to be how far you can push custom scaling in Windows today. And basically, this consists of requesting an RDP remote session make it 8K. And at 8K, you have plenty of room to support 500%, and you still have more than the size you need to run any application. So that you can then connect to that remotely and run your application and look at it a small piece at a time. Yeah, well, it depends. The other alternative, of course, would be to get something like that big Dell workstation, and then you could see almost all of it at a time. But I wanted a solution that would actually work for anybody. And so this is a solution that will work for anybody. Any test team should be able to set this up and run it. So I'm going to try to do a quick demo of this. I will warn you ahead of time that this is the most fragile part of the whole thing, because it relies on my own network connection here. All right, I'm going to try to log into this other machine, and oh, that looks good. Um, now we'll see whether it's, yes, yes, all right, one more. That's the modern logon screen it's processing. And there we are. That's the desktop at 500%. Recycle bin looks beautiful. That next icon is it's got a little bit blurry. It's probably being scaled up. I will just say that there are bugs. The start button's a little small. The store's a little small. So clearly, we have work to do to get to 500%. Fortunately, we've got time to do that. Over here, you can see also some things that are small, and that it looks to me like that speaker thing probably is being scaled with some kind of funny bitmap scaling. So this is a really great tool. It works. You can go in there and, let me sign out from this. Run your app. You can find all the bugs at a very high value, and then you can scale back down. You can say, well, I'm not really going to worry about 500% this year, but I know I'm going to need at least 350, because I know that's coming within another year. So out of all my bugs, which ones look bad at 350? Okay, there's my top tier. Let me fix those now. And this gets you out from being behind this continual curve where the hardware comes and then you have to go back and adapt to it. And it gets us out from behind this curve as well. So we're very, very pleased to have this. We will have a full white paper describing this and a bunch of test scripts for setting it up. It relies on some registry keys that we would rather people not monkey with directly. But for testing purposes, we assume you guys can do that, and we will wrap up some nice scripts so that things get cleaned up properly if you use those. So just stay tuned. Come back to the build site probably in about a month, and we'll have an update on this talk with all the details. So there's the call to action. When you add your high DPCI support, if you haven't already done it, test it all the way up. Do your prioritization as usual, but fix with plenty of headroom, because we think you're going to need it. And that way we can stay ahead of the stream. I'm doing well here. So let's move past that. Let's talk about the assets issue now. If you've got a large complex app, or you're creating one that has dozens, hundreds, even thousands of little icons for UI controls, it can be a real challenge to create those at all the different scaling levels. So what I'm going to say first is, think about whether you actually need to have them at every scaling level. There's an excellent talk that I think Peter Torr is giving on scaling for the universal app model. I'll have a reference to that later on in the deck. And he's basically asserting that depending on the complexity and quality of your asset content, you may be able to just supply a couple at the extremes and maybe one in the middle, and let the system scale them down from high to low. And the results are often very good. He argues that he actually did a double-blind test with some of his developers to prove it, and they were unable to pick out the hand-tuned versus the scaled-down versions at some of the lower densities. Now, this is obviously going to depend on what your artwork looks like, but the point is, you should make an intelligent decision around that so as to reduce the number of assets you really have to create. The other problem with fixed assets, though, is they don't really future-proof you against these possible scale levels unless you go ahead and develop like 500% assets right now. So an alternative that we've suggested before, and I think is going to keep coming up more and more frequently, is the notion of moving towards vector assets. We actually have a delivery mechanism for those in color fonts. They're supported through DWrite, so they're available in places like HTML and in the universal Windows app models. And they make really good containers for vector graphics. And there are third-party tools out there now that will let you take things like vector output from applications like Illustrator and dump them into these fonts. And they look great at any plateau, any scaling level, and they look good in between, too. So if you think of scaling as a way to abstract differences between devices at different densities, going to vector assets can really complete that scaling abstraction for you. And I'm going to give you just a quick demo of one of these. See that? Good. Where is there's the font file. There's Color Fonts demo. So this is, we had the real artwork for the various teams and so on, but we decided we didn't have rights to use that, so we invented others. But the score is real. So this is just something you can imagine creating. And this happens to be an HTML, which uses dwrite. And you can see that as I'm scaling it quickly, it's going to be using some bitmap scaling, but once it gets settled, it re-renders it really sharply and crisply at almost any size. So this is a wonderful thing from a visual quality perspective. It's also awfully nice from a developer perspective because it's just really darn easy. You just need to be able to put text. If the framework you're using supports color fonts and text, you're there. So like, okay, there's the, well, that used to say ESPN. It does not, it says sports now. But you could say this, that thing there was just a glyph, and you basically this HTML is nothing but a little table. How hard can that be? So in particular, if you've got a UI of some kind where you want glyph-like material or icons, and you want to have any kind of alignment with text, you get it for free with the color fonts. You get the vertical alignment and the horizontal alignment right out of the way that the fonts are defined. So this is an excellent technology to be looking at. As I said, there is third-party tooling. We're very interested in driving this into more of our stuff in the future too, so that the tooling story will probably improve, even if it's all third-party based at this point. So there's the color font thing. They are a little harder to author right now. The tooling is not as ubiquitous as it is for bitmap assets. It requires a different kind of expertise, but it's easy to build that up, and the tooling that's available today is actually fairly cheap. So, all right, so that was that demo. All right, I wanted to come back to one thing here. This is really important as we're moving forward. We introduced per monitor scaling or per display scaling only a year ago in Windows 8.1. Prior to that, all monitors attached to a Windows system had the same scale factor, for better or worse. And then what that basically meant was that if you had a high-density device like this or this, and you connected it to a low-density device in like an extend mode, then content was the wrong size, and you would move it across, it'd be too big. And by adding the ability for that second monitor to have its own scale factor, and by using bitmap scaling, we can get it to the right size. And what we put out as the call to action at that time was start thinking about making sure that your own app scales itself and rescales itself as it's moved or as the basic per monitor display factors are changed, which the user can also do. We've come to understand that this gets really critical in docking scenarios. The solution we delivered is really fine for projection, because in projection, things are a little bit blurry anyway. There are optical issues. This is not exactly flat. The lens, probably the focal plane is not exactly quite a plane, many issues like that. And so if there's a little bit of blurring from bitmap scaling of content, you probably are not going to notice it. However, if you have the same experience on a beautiful LCD display, especially if it's relatively crisp and high density, 2 feet from your eyes, you will see the blurring. And depending upon your tolerance for those issues, you may not just be completely unsatisfied with it. So we've had some very strong feedback that this is something that we need to make sure that applications do a better job. Here again, if we talk about the Windows runtime, the framework scaling for XAML and HTML does this for you. In Windows 8.1, it is also per monitor scaled. But since it's scaling at the vector graphics level, you don't have the bitmap scaling except maybe sometimes for assets. And so the result is usually very crisp and clean. We don't have a solution like that for like the traditional GDI Win32-based application developer. GDI was just not designed for that kind of fast and fluid rescaling experience. With a lot of work, you can implement that, and some applications are starting to do that. But it's not nearly as easy. The one thing that is a little bit easier is if you've got WPF applications. WPF does have basically a scaling framework. It has a root transform. And we showed last year how you could go in and modify that root transform to get per display scaling. We never ended up actually posting that sample, and I know a lot of people were asking for it, but we've done work over the last year to kind of improve it. And so there is an updated sample. I've got links to it in the slide. So if you have WPF investments, take a look at this, because you can see how to make some of your applications look a lot better in these docking scenarios. And as I say, this is going to become really important moving forward. I will just point to it briefly. I don't really have time to walk through the code on this one. But if we switch here and we look at, I can put you away now. And I'm going to keep that one up. Here we are. So this is this is basically it. I'm just going to build it so you can see it running. And I will bring forward the display panel. And you can see that as the scaling is adjusted, it does rescale itself. It's a little bit fun. The window as a whole is rescaling itself. I think the experience here is a little bit odd because we're going through the projection. But so the code is all here. There's also a white paper on it, which I can bring that up. Yes. So both of those links are in my talk, and I urge you to go take a look at that and see how all the pieces hang together. If you were at the talk last year, we kind of went through it in some detail, showing where you have to basically do things like declare the application to be per monitor aware so that Windows will not try to scale it, and then where you have to actually update the root transform. And so all of that's been reworked and made a little bit cleaner here. So kind of to sum up, the display trends are continuing to move even faster than we had predicted. I'll just say that the notion of a 4K 15.6-inch display was something that we originally thought was next year, and Toshiba proved us wrong. We're delighted to be proven wrong this way, but it does make having a good scaling story more urgent for both us and you. And it becomes a competitive advantage if you get on board and your competitors don't, but a disadvantage if it's the other way around. And because as we get to higher and higher ratios between like a 250 or maybe a 300% scaling in the future and a 100% desktop monitor, it's really important to be able to do these docking scenarios properly and to rescale the application as needed on the fly. And finally, it's really important to test past the limit that Windows supports right today, namely 250 in the recent update. Go ahead and test to 350, 4, even 500. See what you've got in there and get it cleaned up so that you'll be future-proofed. Let's talk a little bit about input. On the input side, there's also been a lot of form factor innovation. I had a picture showing the display curving. I wanted to show something similar for input. You can't quite do it the same way because it's not like the devices get measurably more precise or refined. But it's an interesting pattern of innovation popping up over really just the last 5 or 6 years. For the fun, I went all the way back to the beginning. The keyboard was supported as part of the IBM PC long before Windows even existed. MS-DOS used it. People may not remember that, but when Microsoft introduced Windows to 1.0, a lot of my devices did not have hardware. There was no hardware mouse. So Microsoft actually built a board, and I found one a few years ago and kept it as a souvenir. We actually made a board that you could plug a mouse into, and you could plug that into your PC, and that way you could run Windows. So we did that effort to kind of seed interest in going into a GUI programming, or GUI user environment. So that was like 1985. So even the mouse is only, 30 years old now? Speech, we introduced speech in a decade later, 1995, with the first kind of separate packet you could apply to Windows 95, or I think also Windows NT took it. SAPI 1.0. And then things start getting a little bit more fast and furious. We introduced Pen with XP Tablet Edition in 2000, and I guess that's probably 2003 or 2. There was another edition of Speech that came integrated into Vista a couple years later. And then we had the original Surface Table with touch and gesture support. We put that into Windows 7 a year later. The Kinect came out with the Xbox a year after that. There's a new version of Kinect for Windows. You heard some of that at the keynote, I think, this morning. It contains motion and speech, and there's definitely a programming for Windows aspect for that, not just the Xbox. And then finally, in Windows 8, we went back and we looked at all of the data points that are in green represent somewhat similar kinds of input. You can think of them as like old-style X-Windows locator input. And we called them pointer. And we basically said, we're going to integrate these things into a new kind of event called pointer. Pointer can wrap mouse, it can wrap pen, it can wrap touch, and who knows what it might wrap in the future. So we made a strategic bet that there was an abstraction here that we wanted to put into our platform. And so abstraction, that's, again, the key message here. We looked at these different devices and we said, what are some common denominators? And then what are the important differentiators? We want applications to be able to start with the common denominator, this kind of basic locator event, something that basically you can get like a down and a move and an up, because all those devices can generate the logical equivalent of those abstract events. And that's exactly the kind of support you need for most desktop apps, which are written to mouse, and 90% of the user input with the mouse is going to be click, move, unclick, or just click. Occasionally there'll be like right clicks as well, but we can also incorporate that within the abstraction. So we said, let's create this thing. Then that provides basically a new level of abstraction that all applications can start coding for. And then we have all the extra richness that goes beyond that. So for example, there are differentiators, things like pressure and tilt. Pressure you can get from a pen or from touch on appropriate devices. Tilt is pretty much a pen thing. Contact, that's the area your finger's in touching, so that's a touch kind of thing. So there's a lot of extra rich data that you can also get. Some mice come with like 5 buttons. No other kind of device does that. And then there are ways you can move that user experience that you've designed forward for specific form factors. So if you are Photoshop of the world, you probably want to start using pen pressure if you've got it, because there are amazing things you can do in artistic contexts with that. We provided a mechanism for apps to get that rich data on demand. Basically, you get the kind of the locator event telling you something's happened, and then you can respond to it and get more data. And then there are very advanced things you can do with those pointer messages and processing. With touch, you have multi-touch. With touch, pen, or mouse, you can take that information and feed it to a gesture processing engine and get gestures out of it. So we thought this was a really important big bet. We started doing this work in Windows 8, and we've been carrying it forward. We've got some great success stories. Even in 8, when we invented XAML framework, we basically said, we don't need mouse specifically in this. We're starting from scratch. We can make this be a pointer-only set of APIs. Now, pointer wraps mouse. So you can write XAML code that basically gets a pointer event, and you can say, is this a mouse? Oh, it is. Can I read the second button or something? And you can do those kinds of things. But the framework itself, the basic input event you get is just the pointer. The web has also been very impressed with this. If you go back 3 or 4 years, you had web mouse events, all very standardized, very historical. You had touch events coming in from a number of different vendors. Apple had some, Mozilla had some. They were coming from all different directions. We decided that we were going to create a DOM event that was a pointer event because it echoed what we were trying to do in the base platform. And we delivered that in Windows 8. And we came up with an interop for how those work with mice. And so, for example, if there's an application that is not ready to receive pointer events, like a JavaScript application, how does its mouse handlers get fired by this? We had all the details for that worked out. And apparently it was interesting enough that the W3C basically said, we like this, can you submit it to us? And so for over a year, the W3C has been working on this, across multiple industry partners. And at this point in time, not only Internet Explorer, but Firefox and Chrome have some early support for this that you can turn on with some of their keys. So we're really excited by this. And the kind of hope here is that you could get to the point eventually where you could write JavaScript code that didn't have to worry about mice. It could just look for pointer. In fact, you could do that today if you were on IE. But with the cross-platform support, you could do that. And it simplifies your life. You can imagine, whether you're talking about this web programming model or XAML or anything else, that if you're writing an application, and on the one hand, you're listening for mouse events that do certain things, and then you're listening for pointer events that really sort of do the same sort of thing, and you have to maintain state here and maintain state there, wouldn't it be really easier if you could just combine that wherever appropriate? And these kinds of developments make that possible. Now, we've talked about pointer and unified pointer before, but I don't think we've talked about it so much from a desktop programming perspective. We've talked a lot about it in web and XAML in previous builds, and I wanted to make sure everybody understood that this is a really important development for desktop application developers as well. And some major desktop apps are adopting this. Last year, when we presented a very similar talk on desktop development, Jerry Harris from Photoshop came and spent about 5 minutes talking about what they were looking at Adobe in with respect to high DPI scaling support, DirectX rendering support, and moving to pointer. And they have not quite released that. I hear it will be coming soon, but they have been very happy with a lot of those investments. One of the developers sent me this a few weeks back. They moved all their painting code to using WM Pointer rather than using a host of different interfaces for different kinds of devices and a mix of mouse and so forth. And as they say, it basically gives them the best painting experience ever. Smooth as butter, I love that. So I think this is a great thing for this application and a great thing for its users. Apropos of that, I should also mention that we expect that the version of Photoshop with this support will be running at both 100 and 200% scaling, and Illustrator is going to be supporting 100, 150, and 200% scaling. And they have done a lot of work to use the GPU for some of the rendering using the DirectX stacks. So this has been a great success story all around, but I'm very happy with what they've been able to do with Pointer. So the question is, do you have applications that would benefit by the same kind of move? And I think, in general, yes. Because it's an abstraction layer, moving forward in some way to using Pointer rather than mouse means that you will be able to incorporate support for future devices as well. So I wanted to spend a couple minutes talking about the way that data flows through the system on the desktop and in the Windows runtime model, because there are some subtle differences. Small, but subtle. So today, in Windows 8 or 8.1, if you've got a desktop application, it's got somewhere in the middle of it, it's got a Win32 message loop. You're processing events coming in off the queue. Those events can be coming from a couple different places. You can be getting pointer messages that are coming from either touch or pen, or you can be getting mouse messages that are coming from the mouse. They're still separate if you're running a desktop application. So the question then is, how does this actually work under the covers? If I've got an old application that only listens to mouse messages, how does it even work with Pointer? Because we know it does. Every one of you has run classic desktop applications on a touch-enabled device and been able to poke things. The answer is that, as with so many other things in Win32, we have the default window procedure, which is hosted in our code. And if you have a well-behaved Win32 application and it encounters a message it doesn't know, it's supposed to hand it off to DefWinProc and basically say, I don't know what this is. Maybe you do. And then we try to work with it in some way. So the pointer messages that are coming in, WM pointer down, pointer move, and so forth, they hit the message loop. The application doesn't know. It falls through the default processing, which means it comes to DefWindow-Proc. And at that point, we've got code that basically says, oh, you're an older application. We're going to turn this into a mouse message and see if you can handle that. And we basically inject a mouse message into the mouse messaging queue, and that goes to the application, and it works. So the end result of this is that the application works with both mouse and touch input. There's a little bit more of a latency with touch because it's got to go through this, we call it promotion into mouse. But it will work. Unfortunately, if you decide to write a desktop application that was only pointer aware, mouse wouldn't feed it. So the difference between this model and the Windows runtime story is that we've added another data flow. If you write a Windows runtime app, Universal Windows apps, we're calling it, then the mouse input stack feeds directly into the pointer messaging queue, and the mouse messages are wrapped as pointer messages. The application gets everything in the form of pointer messages. Once again, if it doesn't understand them for some reason, although in fact almost every modern Windows runtime app would, maybe an exception would be if you wrote a game with DirectX and Core Window. But if something does fall through, we will turn it into a mouse message and send it back. And I was going to just gloss over this one point that this promotion technique where stuff gets turned into mouse is a little bit more complicated. There are cases where we start preemptively doing it for performance reasons. But leaving those data paths out, this is essentially what it looks like. So the reason I presented both of these to you is that you can actually get this behavior in your Windows desktop application today. Any Win32 app can do so. All it has to do is call enable mouse and pointer. It's a simple API. And if you call that in your app, instead of having this picture, we'll take that and redirect it this way. Now, you're probably going to ask, well, why didn't we just do that for desktop apps? Well, remember when I said a well-behaving Win32 app sends stuff? Not all the Win32 apps out there are well-behaved. And we ran some app compat tests, and we found a significant number of apps that do wonky things sometimes with mouse messages and unrecognized pointer messages. The classic case would be an app which is going, oh, the mouse went down. Okay, I'm not going to listen for anything else. Just give me a mouse move or a mouse up. And we give it a pointer move and a pointer up. Says, I'm not even going to give that to DefWinProc. Give me a mouse move or a mouse up. It never gets it. And basically the application hangs after you click the button. So reluctantly, we basically said, okay, this has to be an opt-in. We like this architecture, but we're going to make it opt-in for desktop apps. So Desktop IE does it, for example. It's opted in. And a number of other applications are starting to do that. So with that background, I wanted to just take a little bit of a code dive to explore what you would have to do to take an application. I'm going to take that away. And I'll take that one away. And come back to this one. OK. This is almost the world's simplest Win32 application. I took VS and I just said, give me the blank template. And I added about 3 things. First of all, I said, I'm going to draw a little checkbox. So here up towards the top, I just put in some state. The checkbox can either be checked or unchecked, true or false. There's the coordinates for the little outline of the box. And the check mark is just a poly points kind of GDI line. So right here is the data for that. I just put that in. The second thing I had to do was, as I say, whenever you're implementing a Win32 app, you have to go into the paint handler and draw what you want to draw. So I draw the rectangle, and if it's checked, I draw the polyline. If it's not, I don't. And then I end the paint. Oh, well, one last thing, this has to respond to input. So I have to add a handler for, I'm just going to keep it simple. I'm going to just say, suppose I just do button down. What I'm going to do is I'll test that button against the bounding box of the rectangle. I'll invert the state of whether it's checked or not. And then I'll invalidate the rect, which will cause a WM paint to be sent and will cause it to be re-rendered with either the checkbox on or the checkbox off. Really simple. And this all works. I'm going to, using a mouse, yes. And move the mouse out. I can now do it with touch. And that works. OK, almost the world's simplest Win32 app. Now, it's a bit sketchy. If you were to do a real checkbox control, you would be more sophisticated. You wouldn't just wait for the down. You'd want to make sure that down and up both happened within the same area so that somebody could go, oh, I didn't mean that, and could cancel out of it. But keeping it really simple. OK, so that looks cool. How do you turn this into a pointer app? Well, you put in a case for pointer down in the same place. OK, that looks good. Let's try it. And it won't quite work. OK, we do the mouse. Mouse works. Now I'm going to touch. It doesn't work. The reason is that one small difference. Pointer events are delivered in screen coordinates. Mouse events are delivered in client coordinates. So we have to do screen to client, oops, little l. And we need the h-wind, and we need the position of the pointer, which, since it's going to be changed, we send it in that way. All right, I think I got that right. Nope. Did I misspell green? Yes, I did. Capital T. Yay, OK. Now the mouse still works. Touch works. OK, now my application understands both pointer and mouse. How about if I just get rid of this old stuff? Try that again. Touch, yep, still works. Mouse does not work. Oh, one last thing. It's a desktop app, so we have to enable mouse and pointer, which I had there and commented out. And now touch works and mouse works. So we successfully took it from being a completely mouse-based to being completely pointer-based. Basically 3 steps. You have to watch out for the screen versus client. You have to add the handler, and you have to you make sure that you enable mouse and pointer. Now, in a much more complicated application, you'd have a lot more things to worry about. In particular, a lot of people with large code bases may only be able to move forward parts of it at a time. So you have to be careful that if you're using mouse processing in some parts of the code and pointer event processing in other parts, that you don't hand off the pointer events that you've actually handled to be converted into mouse events, but the pointer events that you didn't handle that are over here, you do. So there might be cases where, just for example, in this picture here, if down where the input handling is, if you imagine that I had this clone for pointer down and for button down again, that if I didn't hit test against the bounds when I was doing the pointer processing, I would say, oh, maybe this belongs to someone else. I'll send this bound to def-win-proc and let them handle it. And then other app controls could actually get the mouse event for that. So just be a little bit careful about that. If you didn't do that here, you would see funny things like you could get the situations where you would touch the checkbox and you would see it draw and then it would vanish. And the reason is it's toggling its state a second time on the mouse handling, just as it did on the pointer handling. It's a very mysterious experience. So there are little things to watch out for, but it's really fairly simple. And then again, once you move the pointer, you're handling all these things without relying upon our architecture to forward events in the right way. And the reason that I think that's going to be important is we've got this working pretty well with all this def-win-to-proc handling. But if we add new input devices in the future, it may get harder and harder to make all the app compat things work exactly the way we would like to. So basically, if you are handling pointers yourself, you're putting yourself in charge of the input. You're not relying on us doing things for you in some particular way. A couple quick questions. People have asked in the past, how does Precision Touchpad fit into this model? Is it like another kind of pointer device? Is it like on a par with pen and mouse? And the answer is no. It's basically like a mouse. We thought that the overlap there was so strong that it didn't justify calling it out into being a separate device type. So if you're doing just traditional mouse interactions with a touchpad, you're going to get mouse messages. Or if you call enable mouse and pointer, you'll get pointer messages. There are some pan and zoom gestures on the Precision Touchpad. And the ways those work are either if your application wants to consume them directly and do something with direct manipulation, you can do so by implementing the register hit test target method and then using direct manipulation. If you don't do that, then we have something similar to the def-win-proc thing where we will fall back and deliver scroll wheel messages so that most application content will pan and zoom the way you would expect it to. Similar question on Connect. How does that fit in? Is that going to be a new kind of pointer ID? Well, I don't know at this point in time. It's certainly an obvious candidate for that kind of thing, and it was certainly one of the things we had in mind when we came up with the pointer abstraction. We knew that there were going to be future devices that could have locator-like events, and you saw from the demo this morning that people were doing things like clenching in order to kind of like the equivalent of a finger down and then moving, like finger move. So you can see how you could certainly map those things through the pointer stack. At this point in time, all I can say is we've done a lot of investment in this area in exposing the Connect to desktop developers, and it's kind of a logical thing you could think of. It sounds like a really good idea, but we don't have anything more to talk about in that connection right now. But stay tuned for the, I guess there's an introductory Connect thing at 4, and then there's one that's been billed for tomorrow, which I think may have some more information. And just keep in touch with what we're doing with Connect. So I guess the basic call to action here is that we think of pointer as our strategic forward direction. It wraps a lot of different things. It makes it really easy for application developers to get started with something that works with a wide range of input devices. If you take advantage of it, as I say, you're taking control of your own input handling. You're basically saying, I want the pointer events, and you know, that way I'm first in line. I can get them. I'm not relying on the system doing things by side effects. You're future-proofing your app against future hardware innovations. You can imagine if we did expose this Connect thing, your application would just work with it. If somebody wrote the appropriate software layer for one of those ring pointing devices that I've seen posted recently, that could possibly just work as well. If you've got perf-critical interactions, it reduces the input latency. You don't have this round trip through def-win-to-proc where stuff comes back as mouse. That's one big reason why Internet Explorer just became completely pointer-based for Windows 8. In order to get those great smooth panning experiences, they needed to do that. Now, if your application is one of these point and click and type text and so on, it probably doesn't matter that much for you. But if it's the kind of thing that people can be expected to interact with touch, it's really important to get that latency down. And then, of course, enable mouse and pointer, because I don't think we'll ever turn that on by default for desktop apps, but more and more desktop apps that are being built today should start using it. So that's kind of a wrap. Just to sum up, we think the desktop development story is really critical, even with all the work that we've done for the unified Windows app model that you've seen. So important, in fact, that you saw from the keynote this morning that we're talking about things in the future like being able to take those Windows runtime apps and put them on the desktop, because we think that user experience is really important. So it's an important area. You've got a lot of investments in these areas. Some of them are hard to move forward into the scaling space, like the ones that are exclusively GDI-based. WPF moves forward more easily. But be trying to push yourself to be as aware as you can be of scaling issues in your applications and unifying your input processing. Some resources for that. The top 3 things here are white papers and tutorials and the like on how to handle scaling in your applications on the desktop. The updated WPF stuff here is the second major bullet. I put a poster to the W3C Unified Pointer specification work that's underway. Great place to go and learn what they're doing with that. If you want to see the rest of that crazy video with the guy driving all the multi-mon scenarios with his little Dell Venue 8, there's a link to it. It looks really fun. And just a last point here, we talk a lot about the Windows runtime as for this new app model, but actually a fair number of those APIs are available to desktop developers. And the link here points to basically an attribute, the dual API partition attribute, that says that a particular API is available directly from the desktop. I expect there'll be more interest in continuing to make kinds of things like that happen. So take a look at that and keep posted with what we're doing in the future at the WinRT. There's a lot of other talks here that I think might be interesting to some of you. The first one in bold I think is really important. If you are desktop developers and you want to get an insight into the future of things, or you have input into how you think it should go, come tomorrow at noon. I'll be there along with some other folks taking questions. And it's a relatively short session, but we're looking forward to getting good feedback on that whole area of desktop development. A bunch of other application, more specific talks here, 3D printing, the connecting I mentioned earlier, Peter Torr's thing about scaling with the Universal Windows applications. Internet Explorer is a web application platform. That can be very desktop focused, but it also has a great scaling story. The 2D graphics has a lot of stuff about color fonts and scaling there. And the developer tools, F12 for Internet Explorer, again, more of since that makes a great scaling story. And then the additional connecting. So I think I have about 2 minutes for questions. That's the end of my formal session. So if anybody's got anything they want to bring up to me, this would be a good time. Yes?
Yeah, I got a question. You talk about the scaling issue. If I have an app written with the WPF, if I embedded the IE, will IE automatically scale with the WPF?
Oh, I don't think I've looked at that hosting scenario. IE scales its own content. It would probably, I'd have to, I'm not sure. I can look into that. I think what will happen is that IE will scale the area it leaves for WPF. But the WPF app is probably then going to have to independently listen for the change event and rescale its own content as well. So it won't happen for free just by being embedded in IE. It'll take work on the WPF side.
Then how about a desktop IE itself?
Yes, in desktop IE. So in desktop IE, the entire canvas, the HTML, is scaled dynamically based on the per monitor display factor. So if you moved IE, or if you adjusted the overall scaling factor, the content would be rescaled. But it's only rescaling the content that it knows how to scale. It doesn't know, IE, Trident, the rendering engine, doesn't know how to scale the WPF content. So I'm pretty sure what's going to happen is you'll see that the area that's reserved for WPF will scale. But then it's up to WPF to rescale its own content so that it fits into that new area. So that would require work from the WPF developer.
Okay, thank you.
Yeah.
I just had a quick question. Even with your expanded overview that included Silverlight, Windows Forms was not listed. Should we be worried if we're using that?
Windows Forms, is much more difficult. It's more like classic Win32. I won't say no, but this would be a good question to bring to the desktop developer panel tomorrow.
Okay, thank you.
Yes. It is difficult. Anything else? No. Okay, well, I'll wrap then. Thank you very much.